Quadratic Functions reference sheet. This is a foldable, so we're going to fold, once we fill out the form, we're going to fold it and it'll kind of do, what do y'all call that, hamburger booklet format or something. And then we'll be able to open it up, close it. We'll show you as we go along. Let's jump into this. Quadratic equations. We're all familiar with that because we've been working with that for the past month? Y equals ax squared plus bx plus c. Keywords that we need to know. These should all be familiar to you. We've got the y-intercept, maximum value, minimum value, parabola, axis of symmetry, and the vertex. Of course, there are other keywords that we might need to know. These are just the main 5. ROXS, acronym, roots, zeros, x-intercepts, and solutions. Now, don't get confused. That O in there really is the number, it's the number 0. It just looks like a O, but it's really R0XS. Don't let that confuse you. Let's look and see. We have 3 cases. Every possible quadratic equation that we have, that we encounter, is going to be one of these 3 specific entities. We will either touch our x-axis at one location, and we're looking here. Hopefully you can see them a little black. Well, maybe not. Okay. Or we're going to cross and touch the x-axis in 2 locations. That means we have 2 real solutions. Or if we do not touch the x-axis at all, we have no real solutions. Yeah, we'll talk about what solutions we do have. We just know they won't be real. Scroll up a little bit. Let's look at some examples. We'll get a chance to look at some of those 5 key terms that we were talking about above, or keywords. So let me make my picture a little bigger so we can see. A couple of things that we want to find. First things first. I'm going to touch some buttons in red or some locations in red. This is my vertex. In the parabola, you kind of say it's the center of your quadratic function or your parabola, however you want to call it. Vertex, as I said, also would be our maximum or minimum value. In this particular case, because our graph is opening downwards, we know this vertex will be our maximum value. Okay? Maximum value, vertex, both of those are the same thing. Let's look to see where we cross the x-axis. I'm looking here and here. These are my zeros. When I'm on the x-axis, my y value is 0. My x value will be wherever I cross the axis. So that's where the zeros come from. What is the value of y? It's 0. We can use that to solve for x, and thus we call those zeros. Now at the same time, if I cross the y-axis, this is going to be my y-intercept. The zeros are also going to be x-intercepts. I think I said that earlier. Just repeating it because it's very important. You will keep seeing this. What else do we have? Axis of symmetry. Very easy to find as long as you know your vertex. What is my vertex? My vertex is the point -1, +1. We're going to use that. Axis of symmetry. We always want to start off. It is the vertical line that goes through the vertex. So start off with x equals, and then we will put the x coordinate of the vertex. That particular value is -1. So my axis of symmetry, because I wanted to go through the vertex, x equals -1. Scroll up just a little bit. Domain and range. Domain's the set of all of my x's on my parabola. The range is a set of all my y's. Let's do domain first. Domain, we're going to go from the left to the right to consider all of the points, all the x values of those points. Because my parabola is going downwards in both directions forever, actually, because it is a quadratic equation, my domain in most cases will be all real numbers. Now that's the M, that's the symbol for all real numbers. It's kind of a funny looking R. Or we can write, because going from left to right, my furthest most value to the left, or endpoint, is -infinity. Because those arrows mean I'm going on forever. And if I scroll to the right, I have every value leading all the way to a positive infinity. Make sure when you're dealing with infinities that you do put the parentheses. Very important. If you put a bracket, you're saying that you've actually reached infinity, and we know we can never reach infinity. If you don't know it, now you do. All right, let's look at a range. Range. I'm going from bottom to top now. So what is my lowest point? Again, looking at those arrows, I'm pointing downwards. So I'm going to start with a -infinity, and I am going to go up. What is my highest point? We can look at my vertex. What is the y-coordinate of my vertex? That is a +1. So I can never reach infinity or -infinity, so I have a parentheses. I do reach 1. So now I want to use my bracket. I think we got everything. Maximum values, vertex, y-intercepts, zeros, axis of symmetry, domain, and range. All right, here's another one. This time my graph, I'm going to do blue. My graph is opening upwards. Draw my little arrows so you can see they're opening upwards. We'll just start at the left-hand side, top, and work our way down. The y-intercepts. Where am I crossing my y-axis? There's my y-axis right here. So I am crossing right here. That's my y-intercept, where I cross the y-axis. You probably remember that from slope-intercept form, y equals mx plus b. We don't have a straight line, so I'm not going to write that equation down. Right? I cannot find my axis of symmetry yet because I don't know my vertex. So let's jump down and find the vertex. There's my little dot. It's my vertex. As you see, my graph is opening upwards, so I this time have a minimum value. That minimum value is -1. I'm looking at the y-coordinate of my vertex. Okay, so here's my vertex. And it's also my minimum value because from this point, all my points lie above that. Okay, so we got the vertex. That is going to be the point 2, -1. We'll come back and use that later. On my x-axis, where I cross the x-axis, those are my x-intercepts, but also we know those to be zeros, because again, the y value is 0. If I wanted to solve for this, I would look to set y equal to 0, and then I can solve for x. In this case, I would find that x is 1 or it is 3. I can now do the axis of symmetry. Okay, see that dashed line? It goes through my vertex. So we, again, want to set up all axis of symmetries by starting off with x equals my x coordinate of my vertex. So x coordinate of vertex is 2. X equals 2. That is my axis of symmetry. Let's look at our domain. Set of x's. I'm going from the left to the right. Now again, my arrows are pointing both directions, so I know it's either going to be all real numbers. I can write the symbol, or I can write the negative infinity. If I go to the right, continuing on to a positive infinity. Every time you have a parabola, if you have those arrows pointing, your domain is going to be all real numbers, leading from negative infinity, ending at positive infinity. My range, go from bottom to top. Because I have a minimum value, I am going to look at the y-coordinate of my vertex. I'm going to start off with a -1, and I am going upwards with those arrows. It means I'm going all the way to a positive infinity. I can never reach infinity, so I put a parentheses. I started off with a -1 where I did reach, so I start off with a bracket. That's what we got for the first page. I'm going to pause this video. We're going to go back, revisit certain things, and we will have a second video for the back side. Welcome back. Page 2 of our, what did we call it? Quadratic Functions, the reference sheet. So let's zoom in to what we're looking at. Here are some problems that we're actually going to work through. Last time we looked at the graphs, located some valuable, or what do you call it, those key keywords. That's what I'm looking for. Now we're going to actually figure out what some of these terms are as far as their values. So as we zoom in to question number 1, we have a parabola. We'll go back to using red. If you notice, your arrows are pointing downwards. So that tells us a couple of things. Our vertex is going to be our maximum point. They ask us what our vertex is. So starting from the origin, we see we're going over -1 and down 1, 2, 3 units. So our vertex is going to be the point -1, -3. Now that is also our maximum point. So when we look down here, it says max min value. So I'm looking for the y value, the height of whatever it is my maximum or minimum value is. So in this particular case, my vertex is -1, -3. So my maximum value is going to be -3. I'm going to underline the word max just so I know I have a maximum value and not get confused to think that maybe there is a minimum value. Now the vertex can be a minimum, but that's only if my graph is opening upwards. And we will see that in a later example. Axis of symmetry. Now notice, the vertex is, I'm going to use a vertex in pretty much most of these key terms that I'm using. The axis of symmetry, the vertical line that goes through my vertex. So in this particular case, as I said earlier, I start off with x equals, and then I want to look and find my x coordinate of my vertex. So x equals -1. That actually gives me a line that comes through. Look at a little blue line. That is my axis of symmetry in blue. Okay, so direction of the opening. Is my graph opening upwards or is it opening downwards? In this case, the arrows are pointing downward. The direction of my opening is down. Let's see if we can find our domain. It's a quadratic function. It's a parabola. And we know that in that case, all real numbers, I just like writing negative infinity to positive infinity. Now, make sure that, I know infinity looks like an 8. Make sure that your 8 is turned sideways. I've seen a few people writing infinity as the number 8. And of course, I mark it wrong because it's not 8 in most cases. All right, so make sure that you turn that infinity or that number 8 sideways so that it looks like an infinity. All right, let's find our range now. So the range, I have my maximum value. I'm going from bottom to top, so I start off with a negative infinity, and I'm going to come all the way up to, what is the y-coordinate of my vertex? -3. I reach -3, so I do a bracket. I'll never reach negative infinity, so I use parentheses. Where's my graph increasing? Okay, so because my domain is all real numbers, going from negative infinity to positive infinity, when x gets larger, where is my y also getting larger? Excellent question. I'm going to start at the negative infinity because I'm going from left to right just to see. And I am going to go to the x-coordinate of my vertex, and that's where I would change from increasing to decreasing. So from negative infinity to -1. Okay, I reach -1, bracket. I never reach negative infinity, parentheses. If my parabola is all real numbers and I've gone for increasing from negative infinity to -1, I really don't need to look back at the graph because it has to go from negative infinity to a positive infinity. I mean, a -1 to a positive infinity. I'm going to look at the graph anyway because I see as x gets bigger, my y now is getting smaller after x equals -1. So I am starting at a -1, and now I am going, because I'm going left to right, to a positive infinity. Hopefully that made sense. Let's move on to another problem. And we'll speed this up a little bit because I don't want to be too long on this. All right, what's my graph doing now? As we look at it, this time my graph is opening upwards. All right, I'm gonna keep working in red. So you see my arrows are pointing upwards. So let's start off with, I'm gonna separate these two. That's problem number 1. So what is my vertex? In this particular case, it is my lowest value. All right, looks like I am about at a 1 and a -4. So my vertex is 1, -4. Now remember what I said. The vertex is going to be used to fill out the majority of these other options, as we saw above. So I know that my graph's opening upwards, so my vertex is my minimum value. And what is the y-coordinate of that vertex? -4. So my minimum value is -4. Axis of symmetry, the vertical line going through the vertex. So once again, I am looking for this vertical line. I start off with x equals, what's the x-coordinate of my vertex? It's 1. The direction of the opening, I'm opening upwards. Okay, look at the 2 arrows. That's the direction your graph is opening. Domain. It's still a quadratic function. It's a parabola. So I will have all real numbers. I still like to write negative infinity with the parentheses to a positive infinity. My range. I'm going from bottom to top. So my lowest or minimum value is -4. And because my arrows are pointing upwards, I am going to infinity. I never reach it, so I use parentheses. I start off with -4. I use a bracket. Where's my graph increasing? In this particular case, it's about the vertex. It's either to the left of the vertex or it's to the right. The vertex point either begins or it ends, whether I'm increasing or decreasing. So increasing, I will start at 1 and I will go to infinity. Parentheses around infinity, bracket around 1. So I just need the other opposite option to do decreasing. So when x gets bigger, my y is getting smaller, starting at a negative infinity, leading up to a positive 1. I'm including that 1, so I use a bracket. Never reach negative infinity, I use a parentheses. Okay, feel free to rewind, go back and revisit some of this if you had trouble with any of these 8 terms. Vertex form and transformations. This is our generic form for vertex. Highlight that. And the A indicates what? Hopefully you remember this from the anchor chart I have on the board and the numerous times that I said A determines whether I am doing a vertical stretch or shrink. Stretch or shrink. And I wrote too large. Okay, see if we can fix that. We don't want to write too big. Vertical stretch or shrink. It also tells me if I reflect across the x-axis. The H indicates the horizontal shift. Horizontal shift, and the H is the x-coordinate of my vertex. The K indicates the vertical shift, and that's the y-coordinate of my vertex. Okay, so we have f of x equals a parentheses x minus h squared plus k. If I can find the vertex h and k, and I can determine whether a, which I could actually find for my standard form, I can write the vertex form without really doing any mathematics. So let's look at a few. Gave us 4 problems. All we want to do is find the vertex using this form up here. Okay, so we have y equals parentheses x minus 2 squared. Okay, now let's look and see. Notice there's not a k being added. So I know my k is 0. I'll just find that first. Does not really matter the order. X minus, what am I subtracting? X minus, so my h is a 2. Okay, using the formula that we had up here, I'm looking for that h. I'm looking for that k. Okay, look at number 4. Now I have x plus 3. My formula says x minus h. In order to make this minus h into a plus, my h has to be a negative number. So -3, because x minus a -3 gives me x plus 3. What am I adding or subtracting to that parentheses that is squared? A -1. So my k is -1. Okay. Let's look here. Ooh, we see that a is -3, but they didn't ask us for a. But just so that we know, anything in front of that parentheses will be our a. So I have x plus 2 with that plus sign. I know that h should be negative. So x plus 2, I have a -2. My k, what am I adding to that parentheses squared? I'm adding 4. And then let's look at this one. Can you see what your a is? A is 2. So that would be a vertical stretch, wouldn't it? I think it would. All right, but now I have x plus 3, just like I had up there. So I know my h is a -3. What am I adding? This time, instead of subtracting 1, just like number 4, I'm adding 1. So my k is a +1. All right, let's look at our last page. Well, it's connected to page 2. Now we're going to graph. Remember that 1, 3, 5 method? We may end up using that. Okay, so we want to graph g of x equals x squared plus 4. Can I find my vertex? There's my x squared. I don't have an h because I'm not subtracting anything from that x squared. So I know my vertex is, the x coordinate is 0. What am I adding to x squared? I'm adding 4. My vertex is 0, 4. Remember what I said? We're going to use vertex for a lot of these. Maximum, minimum value. We don't really know what the graph is, but if we were to put it into the system, we know we have the parent function x squared. We're going to shift over or shift up 4 units. So let's just say 1, 2, 3, 4. And I am going to just default and sketch my graph. All right, now we could do the 1, 3, 5 method if we needed to. We may come back and do that. So my vertex is my minimum value. I'm going to underline minimum, and that's my k value. My minimum value is 4. Axis of symmetry, vertical line that goes through my vertex. And I find that I always want to start with x equals, and the x coordinate of my vertex is 0, so x equals 0 is my axis of symmetry. Okay, so transformation form, we went from x squared, f of x, to g of x, which was x squared plus 4. We know that that is a vertical shift up 4 units. Okay, feel free to go back and rewind this and watch this again if you need to. Let's look at our next problem. Now we're going from x squared, our parent function, g of x. It is a negative parentheses, x minus 1 squared. So where's my vertex? This is the exact same thing we did in the previous, on the previous side. What is my h? X minus, what am I subtracting? Subtracting 1. And I'm not adding anything to that x squared, so this time my k value is 0. Okay, let's see what that graph looks like. That negative tells me I'm reflecting across the x-axis, and I know my vertex is the point 1, 0. So I have 1, 0, and I'm not stretching or shrinking, so my graph is opening downwards. All right, I may not have gone through all the points. We see that this is our maximum value. I'm going to underline the word max. And in this particular case, what is my y value? My vertex, it was 0. So that is my maximum value, 0. Axis of symmetry. What's the vertical line that goes through my vertex. We know x equals, starts it off. What is my x-coordinate of the vertex? X equals to 1. And the transformation, what am I doing? I am reflecting over the x-axis. And then I am going to shift 1 unit to the right. So horizontal, that doesn't look like horizontal. I'm just going to say shift right 1 unit. Okay, practice. Describe the transformation. So we don't have to draw a graph. We do need to know what A is, H, and K. So let's just underline. There's my A. There's my H. There's my K. A is 1/3. That is between 0 and 1. So look at your anchor chart. If the absolute value of A is between 0 and 1, I know that I have a vertical shrink. Vertical shrink. I have x plus 2. I'm looking for x minus h. So I know that my h is -2. So that's going to shift I left out the A, the I. How do you spell shift? Okay. Shift 2 units left. And the third transformation, my K is 1. So shift up, or 1 unit up. All right, let's look at 10 and then we can call it a day. I still have a negative out front. There's not really any parentheses, so how do we determine that? There's no parentheses, so I will assume that this negative is equivalent to being inside of that. So this particular case, because it's a parabola, we are going to have a horizontal So this is my B. If B is between 0 and 1, that is a stretch. Very good. Horizontal stretch. Now, this is on the anchor chart that we have above. I am also going to reflect, because of that negative, over the y-axis. Why is it the y-axis? Because that negative is not out in front of that whole parentheses. There is no parentheses. So all of this is my B value, which we've not really discussed much. Okay. Do I have any shifts? H or K? My vertex is actually 0, 0. So those are my two options. I have a horizontal stretch and I reflect over the y-axis. Okay. Now, feel free to rewind or watch the previous video. If you have questions, you missed something, if all else fails, ask me. This will hopefully help you for any upcoming tests that you have. Best of luck to you. And remember, math rocks. Thanks so much for listening.